Good morning, everybody. This is Honors Geometry, Chapter 3, Section 5. Chapter 3, Section 5. So this is 3-5 notes. And this is part 1, I guess you can say. But in 3-5, the main idea is overlapping triangles. So overlapping triangles, what are overlapping triangles? Overlapping triangles are two triangles that are together in the same diagram. So these two things, these overlapping triangles, they're going to share one diagram, and they most likely share an angle or side. Sometimes they share that common angle with addition or subtraction, but most likely they're going to be sharing a common angle or side. So what we have to do for these overlapping triangles, we're going to translate them out. We're going to slide out two triangles. Okay, so it's okay to dilate. Just don't rotate. So what that means is you might have a diagram like that, like this. And you have two segments going here. And I'll put point A right here, B, C, D, E, and F. In this diagram, the overlapping triangles are here. I'll do them with brown and purple. So here's one. And the other triangle is here. So you can see they share a common side. So again, you're going to slide out the two triangles. You can do it in your head or whatever, but the idea is to dilate them if you want. Just try not to rotate them. There's the purple one and the brown one. And then we can label them. This is D, point D right there. This is point E right here. This is point C right here. This point right here is D. This one is C. And this is B. Okay, so my hope is you can see the reflexive side. Right, there's the two sides they share in the diagram, but I slide them out, I translate them out, and I dilated them a little bit, but I just didn't rotate them. So we are going to do a practice proof. Okay, with overlapping triangles. So the diagram that you're going to be given is similar to the example. There's a triangle there. And there are two segments here. And it's labeled with an A there, an E here, a D here, an F in the middle here, and C here, and B here. And right here is a 1, and right here is a 2, and here is a 3, and here is a 4. And in this proof, we are given that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And we are proving that BC is congruent to ED. Okay? So if you can see the two triangles, that's great. You should take them. So taking them out would look like this. Take this triangle out here. And I'll label it with an E here, a D here, C here. And we'll take this triangle out. And this is a B here, C here, and D here. And we're given angle 1 is congruent to angle 3. Now, if you notice, angle 1 and angle 3 are not part of the triangles anywhere. But angle 2, okay, is right here. Angle 2 is angle ECD, which is right there. And angle 4 is this angle right here. And we see that 2 and 4 are equal. All right, so those angles are congruent. And then you also have this reflexive side. Okay? Now, look at angle. This problem is really tricky, but you got to see it. All right? And we're going to do the proof. But angle 3 is congruent to angle 1. And angle 2 is congruent to angle 4. So if we add 3 and 4 and 1 and 2, we're going to get the same. That's addition. That's congruent angles added to congruent angles. So those two angles are here, see? This is 3 plus 4 right here. And right here is 1 plus 2. So this angle is angle 3 plus angle 4. And this angle right here is angle 1 plus angle 2. And since 1 and 3 are equal, and 2 and 4 are equal, 1 and 3, 2 and 4, then their sums are equal. Okay, so that's what we had to see. That's what we should try to see before we set out on the proof. And we look for that, and I'm going to do a 2-column proof with a statement here and a reason here. And I'm going to say angle 1 is congruent to angle 3. That's given. And the second one is angle 2 is congruent to angle 4. And that's given. Okay, we have to prove BC is congruent to ED, right? So if we get the two triangles congruent, we can say BC and ED are congruent by CPCTC. But we have to get the triangles congruent, so we are going to next say that the sides are reflexive. So I can say that CD is going to be congruent to DC. So CD is congruent to DC, and that is reflexive. Now we're going to get angle D congruent to angle D, but it's not the same, or I'm sorry, angle D is congruent to angle C, but we have to say BCD and EDC. So the fourth step is angle BCD congruent to angle EDC, and that's addition. The fifth step in this proof would be that the triangles are congruent by angle side angle now. Okay? So triangle, oops, I can just use the order of the angles. Triangle BCD is congruent to triangle EDC, and that is by angle side angle. Now the first angle is going to be, you see, it's going to be 4 and 2, which is this one, because this was angle 2 and this was angle 4. We can see them up here. So the first angle is going to be 2. The side is the reflexive side, and then the third angle is this angle here. Now we had to prove that BC and ED were equal, so we are done if we say that BD, what is it, BD? Yeah, no, BC. BC is congruent to ED, and that is CPCTC. Corresponding parts of congruent triangles are congruent. That's the reason that BC and ED are equal. Now let's review the section and the proof. So in this section 3.5 we have overlapping triangles. Okay, overlapping triangles share one diagram, most likely share an angle or a side, which is the reflexive side. I always suggest to students to slide the triangles out. It's okay to dilate the triangles, but don't rotate them. All right, don't try to keep them rigid. All right, but don't like rotate them. Okay, so for example, see the two triangles here. We slide them out. Okay, here's a practice proof. We did a practice proof with overlapping triangles. Given angle 1 is congruent to angle 3, which we have here and here. Angle 2 congruent to angle 4, which we have here and here. We recognize that the two triangles are triangle ECD and triangle BCD. We take them out. And then we had to come up with an addition property here because angle 3 and angle 4 make up EDC, and angle 1 and angle 2 make up BCD. And since 1 and 3 are equal and 2 and 4 are equal, the addition property applies. Because you could say something like, you know, I'm going to write this real thin, if angle 1 was 40, and angle 3 would also be 40 because they're equal, and then angle 2 was, say, 30, and angle 4 was also 30 because they're equal, well, both of them are 70. See, that's where the addition property comes in. Let me erase these things here. Okay? So that's the addition property. And then we went ahead and did our proof. We put our two givens down. And then we recognized that there were overlapping triangles. We used a reflexive property there. And then we said the triangles, we said we needed that addition angle. And that was BCD and EDC. And you can see the reflexive side here. See CD and DC, CD and DC, CD and DC. Anyway, that's how we get the triangles congruent, angle side angle. And then the two sides are congruent by CPCTC. Okay, so there's your 15-minute rundown of 3.5.